Benchmark 15. This one can be a little complicated for people, but it's actually fairly simple when you understand exactly what it's asking. Now, these are just basic properties of rational equations, logarithmic functions, radical functions, and exponential growth and decay functions. So what happens here is it's basically asking if x is a real number, what values for x make it false? Meaning which values do not work. So if I factor the top, and then if I cancel, and then when I try to solve, I get a false statement. Now this false statement means that there are no real solutions. So if there are no solutions that work, what makes it false? Everything. So everything's going to mess it up. So that's kind of interesting. False means what doesn't work, and everything doesn't work because there's no solutions. You got to be careful with the words false and true. This one, if x and y are real numbers, which value or values of x make the function true? So what values would work? Well, with the log, this is a natural log, but all logs, you are not allowed to have the inside here become a negative or 0. You cannot get a negative or 0 in here. So if you cannot let it be a negative or 0, that means for it to be true, it has to be positive. So what's inside, the 3 minus 4x, must be positive. And the way we say positive is greater than 0. So this in here has to be positive, which is greater than 0. And then we just solve it. So what that means is x values less than 3/4 work. So what wouldn't work are x values greater than or equal to 3/4. That would not work, or you could say make it false. Next one. If x and y are real numbers again, which value or values of x make it false? So for a function like this, for a radical, you are not allowed to have negatives in the square root. So we're looking for false, we're looking at what we can't do. So the 2x minus 1, what can it not equal? It cannot equal a negative. And the way we say negative is 0. Alright, so the way we make negative is 0, the way we make negative is less than 0. Now, so what is false are any values that would be less than 0, because we cannot plug negatives in. Now, can we plug 0 into here? Can we have a 0 inside of a square root? Yes. So what makes it false? We just solve this, and x values less than 1/2 would make this false. Greater than or equal to 1/2 would make it true. So both these are very similar. The key here is for both these is check if it's false or true. And then after you check if it's false or true, then what you want to do is you want to go, okay, set it up and go, okay, for instance, again, this was true, so I wanted, for logs, that means it has to be positive. So greater than 0. Now, you cannot plug a 0 into a log, that's why it's not or equal to. You can plug a 0 into a square root, and that's why, because of false, false is saying not true, that's why it's just less than 0, because negatives are less than 0. Okay, you just got to be careful again. You can plug a 0 into here, but you cannot plug a 0 in here. Neither of these can you plug in a negative. So just be careful on the true-false idea. One thing with this problem again, before we go to number 4, this one, what value could you not plug in right off the bat? Well, you could not make the bottom here a 0, so you couldn't plug in a 5/3, because a 5/3 would make this 0 on the bottom. But once we get to the bottom, we realize everything doesn't work, so we don't have to worry about that 5/3. Okay, last one. What x and y values are real numbers, if they are, what are the possible value or values of y? Basically, what are the outputs? Well, first you have to realize, covering that up, that's a growth. H is bigger than 1, so it's a growth, so it looks like this. And then what you realize is minus 5, all that does is take your growth function and drop it down 5, meaning your asymptote is now at -5. It used to be at 0, it used to be a growth at 0, asymptote at 0, but now since it's minus 5 it moved down 5, so your asymptote's here. So basically what happens is your graph is a growth, it will never go across the asymptote, so your y values must always be greater than -5. Now if it said what don't work, well that would be values less than or equal to -5, because it will never touch that or get below the asymptote. Because the definition of an asymptote is a line you're approaching but never crossing. So, again, it would be all values greater than -5. Hopefully this helps.